All right, so let's see, which one is this? This is the 4i handout, which mainly talks about something called altitudes, which you may have heard of before for triangles. And altitude is often used synonymously with the word height of a triangle. Um, and so each triangle has three different altitudes because it depends on what point you're drawing it from. Um, so the way that I think of altitude is of a triangle is kind of like the height of a mountain, where you pick a point to be the peak of your mountain, and then the side on the other side. So, like, let's say we pick A, right? We pick A to be the peak of the mountain, and that means that BC, if I extend it, that's the ground, right? So, drawing the altitude from A to side BC, the key for the height is you don't measure the height of a mountain by going down the side. You go straight down to the ground. And the key about this is that when I draw it straight down to the ground, it makes a right angle. Okay, so when you draw these in, try to make them look like you're actually getting right angles. I don't want to see stuff that looks like that and say, oh, that's 90, because it doesn't really look like 90. That looks obtuse. So do your best to really make that look like a right angle there. Okay, so what I've done, sometimes it's easier to rotate the page to sort of see how this works. I can't rotate the page, but what I can do is I can actually rotate the triangles. So here's the first triangle. Oh, let me go back to this first. This is the altitude from A to BC, from point A to side BC. So let's do one from B to side AC, and then another one from C to side AB. Okay, so let's come back over here where I can actually rotate the triangles. So if I'm doing it from B, then I think of B as the peak of my mountain and AC as the ground. So I want AC to look flat, like that. Okay, so B is the peak, AC is the ground. And then when I draw the altitude, I just go straight down. There it is, right there. So if I rotate this back, whoop, so if I rotate this right back, oh, the problem is I didn't rotate the diagram, the other thing. So let's see, it goes B to AC. It's kind of close to A here. So let's go back over here. It goes from B to AC right there. And then if you look at C going to AB over here, you can rotate your page. So let me get rid of this part. And we'll rotate. So if C is the peak and AB is the ground, you can rotate your page so it looks like that, and then it's not too hard to draw straight down from C to where it hits AB at a right angle. So in this case, it's closer to A also. So if I come back over here, starts at C, makes a right angle a little bit closer to A. Okay, let's take a look at the right triangle version. So this one's acute triangles, right? This one will be right triangles. They're all identical triangles, by the way. And then down here will be obtuse. So right triangles, if I'm going from A to BC, then A is my peak and BC is the ground. So let's come back over here. And I've got a right triangle down here, the same right triangle. And if I rotate it so A is the peak and BC is the ground, notice that the height of the mountain, let me rotate it just a little bit more. The height of the mountain from A, all I do is I go straight down, right? So it's actually side AB is that altitude right there. So it's this. That is the altitude. If I started at point B to side AC, then B is the peak and AC is the ground. So if I come back over here, and I make B the peak and AC the ground, kind of look like this. And I'm just going to come straight down from B to AC. and it'll be a little bit closer to A, you might be able to tell. So in this case, it'd be straight up. I practically have to flip this diagram exactly over. So there's the altitude. And then the last one, we'll do it from C. So here's point C. AB is going to be my ground. And if you rotate the page, or in this case, I'll rotate the diagram. So C is the peak and AB is the ground. There's the diagram. And if you notice, I would just go straight down to B. Right? That already forms the right angle. So it's side CB. So in this one, here's the altitude right here. Okay, the obtuse ones tend to be the hardest ones. So we'll do from A to side BC, from B to side AC, and from C to side AB. Okay, so from A to BC. So let me go back over here. And here's the obtuse triangle down here. So if A is the peak and BC is the ground, I want BC to look flat. Okay. Let me click on something else here to get rid of that. Okay, so BC is the ground, A is the peak. The problem is, if I measure the height of this mountain, it's kind of like a cliff, like a jagged cliff. It sort of goes out over the ocean or something. Well, the height of it, you don't measure this slant here or this slant there. You measure straight down until it reaches wherever the ground would be. So in this case, you actually have to extend this side here. And where that thing hits the ground is going to be our altitude. So this thing right here is the altitude. Right? So let's draw that in. So A was the peak. BC I had to extend this way. All right, let me use a different color for that. So I use blue there. And this, where it makes a right angle, is the altitude. Okay, now if B is the peak, this one I won't bother rotating here. If B is the peak, then AC is my ground, right? And if you kind of picture rotating the page just a little bit so AC looks flat, then you're going to end up drawing this line in right here to make a right angle with where the ground would be if you extended that side. So this is the altitude there. And then from C to AB, this one I'll rotate because this one's not too hard. So this one, C is the peak, AB is the ground. Kind of like that. This one's not too bad. This one, if I just come straight down from C, it's a little bit closer to A in this case. That forms an altitude right there. So, come back over here. That's really just this. Okay, let's take a look at 2. So 2 says, write the equation of the line that has the altitude from A in this triangle. Okay, well, ABC looks obtuse to me. So if I were to think of A as the peak of the mountain, and then I extend this line, then I'm drawing a perpendicular line to that extension. So it would look kind of like this, something like that. I'm not really sure where it hits down here, but that's my altitude right there. Something like that. Okay, so what I need is, I need the equation of this line. Now, we've been doing all our equations in point-slope form. So point-slope form, if you remember, y minus y1 equals m, x minus x1. M is going to be the slope of the altitude, so the slope of that red line. X1, Y1 is any point on my line. A lot of people might be tempted to choose this point, but I'm not positive exactly where that point is unless my diagram's 100% perfect. But I do know A is on that line. So I'm going to use A as -2, 7. So I'm going to go Y minus Y1, which is 7, equals whatever the slope of that red line is. X minus -2, so x plus 2. Now I still need the slope. of that red altitude. Well, the key to the problem is I know that I can get this slope because I have 2 points on that line. I have B is 2, 4, and C is 5, 5. So what I could do is I could get the slope of this green line right here, right over and up. And when I go across, the x's change from 2 to 5, so that's 3 over. And the y's go up from 4 to 5, so that's up 1. So now I know that the slope of this green line is 1 over 3, and it's positive because I'm going uphill. Since the altitude's perpendicular, so the slope, so here, I'll write here. The slope of BC is 1 over 3. So that means that the slope of our perpendicular line, the altitude, has to be the negative reciprocal. So I flip them, and I switch the sign. Negative 3 over 1, or negative 3. So that's what I'm going to plug in here. So the equation of the altitude from point A is going to be y minus 7 equals negative 3 x plus 2. Okay, I hope that helps a little bit, and I'll see you guys soon. Okay, so let's take a look at 4i. This is 4i, right? Yeah, number 3. So this goes back to the previous homework assignment, and what I've done is I've already filled in some of it for you. You had this triangle here, ABC, and then you had to find the equations of 2 of the medians. So n is the midpoint here, and am, where m is the midpoint of this side, AB. And it turns out that 2 of the equations you could have come up with for those medians are down here. And I've already given you these 2 equations. There are other versions as well, but if you graph them, it's actually the same line, even though the equations look different. But so we already learned if you graph all 3 medians, you can find this centroid point by just averaging the coordinates of the corners. But I want to be able to do this using the equations themselves and your graphing calculators. So what we're going to do is we're actually going to graph this line right here, although the calculator won't know that it ends, so it'll graph the whole line. And then we're going to graph this line right here. Because we have their equations, we'll graph them on the calculator, and then we'll tell the calculator to find that point right there. So the way we're going to do it is the first step is we got to write the equations so they're in y equals form. The calculator can't handle y minus 7 equals some junk. So we got to get y by itself. So the first equation, all I'm going to do is I'm going to add 7 to the other side. So I'll add 7 to both sides, which will get rid of the minus 7. So the first equation will be y equals negative 1/9 x minus 2, and then plus 7. Now I'm not going to simplify, because the calculator doesn't care if I simplify or not. Then the other equation, if I get y by itself, it's 7/9 x minus 5, and then we're going to add 4 to both sides to get the 4 over here instead. So there are my 2 equations in y equals form. Now I'm going to go to my calculator. So, and then these are step-by-step instructions here. So here's the calculator, right there. Oh, put it over here. I'll shrink this one down just a little bit. Nope, it didn't shrink. And let me make this a little bit smaller. There we go. Okay, so I'm going to hit the y equals button right here. That's this one. And notice there are all these places to enter in these y equals equations. So I'm going to enter in this one as my y1 right there, and then this one as my y2 right here. And when I hit the x, you could go alpha x every single time, but this button right next to the alpha button is actually a shortcut for x. You can kind of see if I just keep hitting it, more x's appear. Okay. By the way, another thing is, if any of these happen to be highlighted like that, you're going to have to turn them off first. So you're going to have to go back up there, hit enter, make sure none of them are highlighted, or else this thing won't graph right. Okay, so one of the equations is negative. So this button, 1/9, and I'll do 1 divided by 9. If you prefer the fraction symbol, you could do negative and then alpha f1 numerator over denominator, so then it'd be 1/9. And then parentheses x minus 2, and then plus 7. And then the other one's 7 divided by 9. I'm just going to do regular 7 over 9. 7 divided by 9. And then x minus 5, close parentheses, plus 4. Okay, so I've entered in the two equations. Once both equations are entered in, press the graph button on the top right here. So there's one of my lines. There's the other line. If I scroll back up here, this line right here, this line right here is this line. And this other one right here is the one going up there. Now my window's not the same. Like notice this is mainly just the first quadrant and it goes all the way out to like 15, 16. This is -10 to 10 and -10 to 10. So it's not the same size window. But we can see the intersection points right there. Okay. So we should now be looking at a graph of the two medians, if they kept going. Our goal is to find the intersection point. So to do this on the calculator, we need something called the calculate menu, which if you notice, it's in blue right here, calc. So in order to get there, because it's in blue, I have to hit the second button first, the blue button, and then this trace button, which is really now the calc button. And then I'm going to choose intersect. So that's option 5. So you can either hit 5 or you can just scroll down to it and hit enter. Then it's going to ask 3 questions. First curve, second curve, guess. What it's really asking is which 2 lines or curves do you want it to look at? Because sometimes you've graphed like 4 lines or something like that, and it can only do 2 at a time. So so notice the cursor is already right here. It's already on one of the lines. To mark a line, you just hit enter. So I've marked the first line. It knows that this is one of the lines to look at. Second curve, well, it's already on the other line, so I'm just going to hit enter. So now it knows, look at this line and this line. Now it says guess. Guess helps the calculator figure out where to look around first. So I'm going to move my cursor over to here and then hit enter because that's pretty close to where the actual intersection is. So left and right moves the cursor. So that's pretty close. I'll hit enter. And then it actually tells you what the intersection point is. So the intersection point is 8, 6.3 repeating. Now there are times that, the calculator is using these estimation tricks. So there are times that you might get an answer like 7.999999998. And you just kind of have to know, okay, well it's using estimation. That's probably 8, really. Okay. So that's it. That's how this works. There will be some problems coming up that ask you to find intersection points, and you can always refer back to these directions to help you figure it out. Okay. All right. I'll see you guys soon. Oops. How do I turn this off?